Hey, third period. Hopefully you've already taken a look at these two warm-ups that you should have been asked to do when you came in. And so I'm just gonna go over the answers with you. I feel like the first one is a little bit easier than the second one. So let's go through the first one real fast and then spend a little bit more time on the second one. The first one, I bet most of you were able to do this one okay. 40 divided by 4 is 10. 80 divided by 4 is 20. 16 divided by 4 is 4. And 96 divided by 4 is, what is that, 24? I was able to figure this one out because I know that 100 divided by 4 equals 25. That, right? Because if I take 100 pennies and divide it into 4 pieces, I'm going to have 4 quarters, each of which is worth 25 cents. So that helps me remember that fact. And I noticed that 96 is 1 fewer 4 than 100. And so I knew that the answer had to be 1 fewer than here, right? 24 rather than 25. I also see something interesting here, that when the dividend doubled, when I went from 40 to 80, my quotient doubled from 10 to 20. And that actually plays a big role in what they're hoping you'll see in the lesson 2 warm-up. This brain teaser was pretty hard. I'll admit this one. So if you weren't able to get this one, or you weren't even really sure what you were supposed to do, that's okay, don't worry about it. Let's talk about it for a second. And I want you to think about how this connects not only to various things we've been learning in Math 180 and multiplication and division, but also how it relates to what you learned in your regular math class earlier in this year about proportional relationships. Let's see how those are connected. So it says if blank times 2 equals 30, then what is blank times 4? Well, we have to fill in the blank with whatever goes here, right? Something times 2 equals 30. We can work backwards and think, okay, 30 divided by 2, what is that? That's going to fill this box for us. It's 15. And so this 15 has to fill this box as well, right? The boxes need to be the same number. Well, now the answer to my second question is sort of hidden in this first question. 15 times 2 is 30. Now they're asking me 15 times 4. The 2 is doubling to make 4. It's being multiplied by 2, right? 2 times 2 is 4. And so that means that the product here, the answer we get when we multiply the numbers, must double, right? If one of the factors doubles, then the product is going to double. And so 30 times 2 is 60. And this is how proportional relationships work, right? As if one of the quantities went up double, the other quantity had to go up double. If one of the quantities went up like by 7 times and the other quantity would have to multiply by 7, everything kept in step or in equivalent ratios with each other in that way. And that's kind of what's happening here with the number in the box and the product. So if blank times 5 equals 65, so I'm thinking, let me work backwards. 65 divided by 5 is 13. Then what is 13 times 10? Well, to go from 5 to 10, again, we're doubling. And so that means my product, or the answer here, is also going to double. 65 times 2 is 130. Granted, that's probably not the easiest way to do this question, though. You probably just look at 13 times 10 and think, oh, okay, let me just add a 0 on the end of 13. But the relationship still holds both ways. It's nice to see it in both perspectives. Okay, and then lastly, 40 times something equals 80. Well, I know that 40 times 2, sorry, I said 80, but I meant 800. I know that 40 times 2 would be 80. So if I had that extra 0 on there, I could get 800. So this is going to be 40 times 20. And now look, in the next part, they're changing one of the factors from 40 to 400. So that's a times 10. And so that means that our product should also be 10 times larger. So this 800 is going to now become 8,000. That was a really hard warm-up. So if you weren't able to get that without like a lot of help from me, don't worry about it. Like hopefully you see some of the relationships there though, that I'm hoping you see, that if we take a multiplication question and double or triple or quadruple one of the numbers being multiplied, then that's going to make our answer double or quadruple or triple. And that's sort of the basis of proportional relationships that we did earlier in the year. All right, so let's move forward. We're going to do 2 lessons today because you didn't do any lessons yesterday, right? You spent a bunch of time on the computer. And so let's do 2 lessons today. There might still be some time left for you to work on the computer after we do 2. I don't know. I'm not sure. Depends on how long it takes us to get through these. And these are going to be kind of hard. I need you guys to stick with it as best you can. Pay attention to the examples I give you. And then when it's your work time, to actually try it and focus. Don't get sidetracked being silly with each other and that sort of thing. No giving up and saying it's too hard, you can't do it. Just think about the process and try something. All right, and then at the end, I'll show you how to do it if you weren't able to get it. But I need you to give some good effort on this stuff. So like we usually do, let's start by looking at the worked example. Today, what we're doing is more long division, but this time all of our divisors, the numbers that we're dividing by, are 2 digits, but they're multiples of 10. So you're 10, 20, 30, 40, that sort of thing. And so really that shouldn't change much of the process that we were practicing a lot last week, except everything's just sort of reduced by 10. Like we're almost always never going to be able to fill in that first box of the bottom row where we put our answers because our divisor is just too big. That's pretty much the only change that we should see here compared to what we were doing last week. So let me show you what I mean. They're here in our worked example, they're trying to do 692 divided by 20 and see how they weren't able to fill in a number right here above the 6 because 20 can't go into 6. So they could have put a 0 there and filled in a whole row of zeros and moved on to the second row. But instead, what they decided to skip kind of sort of straight to the second step, which is looking at how many times 20 goes into 69. 20 goes into 69 3 times. And so that's where this 3 right here comes from. And they put it on the number, the last number in 69, right above the 9. Sorry about how this doc cam is constantly like focusing and out of focus. I know it's annoying, but this is what I have to work with today. So 20 can go into 69 3 whole times, but then they fill the row. Remember, we always fill our row from there on with zeros. So what we're really saying is we can pull out 30 multiples of 20 from the number 692. And when we check it, 30 times 20 is 600. That's where this came from. And so we've divided out 600 of our 692 at this point, and we subtract down to see that we still have 92 left that needs to be divided by 20. So our next check is how many times does 20 go into 92? Well, that's step 2 here. And they show that they've chosen 4. They're saying 20 can go into 92 4 whole times, which I agree with, because 5 times would make 100, which would be too much. And so you multiply through 4 times 20 is 80, subtract down, and you get this 12 left over, which you can't divide a whole nother set of 20 out of, right? 12 is too small for that. So we're going to let that be our remainder. And if you check down here, the answer is 34, because you've got your 30 that we first divided out and the 4 that came in the second round. And then our remainder 12, because that's what we had left over in that last step. Okay, so hopefully this doesn't feel too much different than what we were doing last week. It's just that divisor is going to be bigger by a multiple of 10 now, which is going to kind of make us it almost allows us to like skip a step. In some way, you can think of it as almost being easier now. So let's do 985 divided by 30. So let's check if 30 can go into 9. Obviously it can't, right? You can't there's no way a 2-digit number could ever go into a single-digit number. So let's just skip that step. And instead think of how many times does 30 go into 98? And if that's hard for you, thinking about those big numbers, trying to go 30, 60, 90, then what you can do instead is just think about the 3 and the 9. 3, 6, 9. Okay, so I can fit this 3 that's in this tens position into this 9 that's also in our tens position. It's really in the hundreds position, but we're only considering 98, not 985. 3 times. And so 30 into 90, 3 into 9 are the same ratios, equivalent ratios like we were talking about earlier again. So I'm going to say that 30 can go into 98 3 whole times. So I'm going to put the 3 above the 8, the last number in the 98 that I was checking. But then I fill my whole row. So I'm going to toss a 0 over the 5 there. And so what I'm doing now is I'm taking 30 sets of 30 out of 985. So you got to do 30 times 30 to see what you've got here. Remember, we do that by doing 3 times 3, which is 9. And then we have 2 additional zeros here. So that's 900. And we subtract down, and we're left with 85. And so now our check is how many times does 30 go into 85? And just a moment ago, we decided that 30 goes into 90 3 whole times. And now we have less than 90, just a little bit. So a little bit of thought, we should be able to figure out it's got to be 2, right? So I'm going to put a 2 above the 5 in 85, always above the last number in the number that I'm checking as my dividend. 2 times 30 is 60. And when I subtract down, I'm left with 25. And I can't put 30 into 25 anymore. So I have a remainder that's small enough to stop. And so my answer is going to be this 30 plus this 2 with the remainder 25. So let's just go ahead and write that all the way down here. I'm moving I'm acting like I'm in my classroom where I move my book under the doc can, but what I need to do here actually is move the doc can itself. So we're going to write 32 remainder 25 here. Let's do 2 more examples together, and then that will leave you with 3 that I'd like you to try on your own. But then I'll also show you the answers to those 3. But let's do 3, and then you do 3. So moving on to number 2, we've got 745 divided by 30. I'm going to go a little bit faster this time though. So 30 cannot go into 7. So I'm going to check how many times can 30 go into 74. Again, counting by 30s, we've got 30, 60, and then 90. 90 is too much, so I'm going to pull back. I'm only going to go 2 times. I put it above the 4, and I fill my row, so I got a 20. I'm pulling 20 sets of 30 out of this 745. 20 times 30 is 600, and I'm going to subtract down. I'm going to get 5, 4, and 1. So now I need to figure out how many times does 30 go into 145. That's a little bit tough, but think of it as your 3s instead of 30s. When I count by 3s, 3, 6, 9, 12, 15. 15, 5 3s. I'm going to do that same thing this time, but I'm going to put zeros on the end. 30, 60, 90, 120, 150, 150, 15 with an extra 0 on the end was 5 30s. It's the same pattern, just with a 0 on the end. And so 5 30s. No, wait, that's too much. What am I talking about? I just figured out that's 150 and I don't have 150. Do over. I can only fit 4. I can fit 4 30s because 4 times 3 is 12. So 4 times 30 is 120. And I subtract down, I get a remainder of 25 again. What are they doing? They're giving us practically the same question again. So this time it looks like my answer is going to be this 20 and this 4, so 24, with a remainder of 25. I'll write that down here at the bottom. I don't know what they want us to do with all this space. It's not really necessary. That's here. Can you see? I'm writing 24, remainder 25. All right, let's do one more together. And then I'm going to need you to try to do the other 3 without me. And if you have time, you can do the exit ticket. The exit will be optional. All right, so first let's set up our question, right? We got to put the dividend, the number being divided, in the box. So that'll be like this. Don't put it up too high, because remember, we got to like stack our answer above there. And if you put it real high, to get all messy. Don't put it too low either, because we're moving down. So I chose somewhere in the middle. I don't know if that's going to work out for me or not. So I'm going to divide this 862 by 20. First thing I'm going to do is check, can 20 go into 8? Obviously it can't. So instead, let me check, can 20 go into 86? Well, if I count by my 20s, it's the same as counting by 2s. 2, 4, 6, 8. With 20s, it's 20, 40, 60, 80. That's 4 20s gets me to 80. So I'm going to put this 4 above the 6 and 86 because I was checking how many times can that 20 go into 86. And I stopped at 80 because I know the next one's going to be way over 86. 4 times 20 is 80. I subtract down, so I just have the 6. Oh no, I'm going back to old style. This isn't how we do it. I'm doing old school style. What I should have done is filled that row with a 0, right? And so I'm really pulling out 40 sets of 20. And when I did that, that would have created another 0 right here, right? I would have got 800 here instead of 80. It doesn't change much. I'm still going to subtract down here and get a 6 and a 2. The old school way I would have done it, we would have talked about bringing down the 2, right? And I would draw like a little arrow here. But instead, this time we're just subtracting the numbers differently. It's all the same stuff in the end. All right, so we got 62. So I'm checking how many times can 20 go into 62? Let me count. 20, 40, 60. Looks like 3 times because the next one's going to be over 62 for sure, right? So 3 sets of 20 makes 60. And I'm left with 2, which I obviously can't put 20 into anymore. So that's going to be my remainder right there. And my answer is going to be this 40 plus 3. So it looks like we got 43, remainder 2 on this one. All right, so I want you all to try the other 3 before I show you how to do them. I want you to see if you can do them on your own without me. I'm not sure exactly how much time you feel like you'll need to do that. I'm going to let that be up to whoever's teaching the class right now, to just pause this video and give you a reasonable amount of time to try these 3 questions. That might be 5 minutes. That might be closer to 10 minutes, somewhere in there. But just go ahead and resume this video when it seems like everyone has either finished the questions or is stuck enough to where they need the help to see how it's done from there. All right, so I'm going to go ahead and finish these from here. Hopefully you were able to get at least 1 or 2 of them done, or you at least gave them a good try if you weren't able to do them, or maybe you got all 3 done and you did great. Either way, as long as you tried. So we got 756 divided by 10. This is actually kind of easy if you know the tricks to these. When you divide a number by 10, it just moves a decimal. And so I know the answer is going to be 75.6, or in this case, 75 with a remainder of 6. But let's do it. 10 can go into 75 7 times, right? 10, 20, 30, 40, 50. We can do that. So I'm going to put a 7 right above the 75. And I'm going to fill my row with zeros. See if I can get this dock cam to stop. Stop. Going out of focus. Come on, you can do it. If I do this a little bit. All right, let's see if it'll stay there for a little while. All right, so I'm pulling 70 sets of 10 out of this 756, and 10 times 70 is 700. So we've divided 700 out so far, and we're left with this 56 we still need to divide by 10, and 10 can go into 55 whole times. And we're left with 6. So our answer is going to be this 70 plus this 5, oops, with remainder 6. Dividing by 10 is pretty easy. The other ones are going to be a little bit harder. We got a 30 and a 20 still to do. Ooh, I can tell right off the bat that this one's going to come out with no remainder, though. If you did this one and got no remainder, great job. So 930 divided by 30. So let's first check on how many times 30 can go into 93. Well, we've already seen a couple times in this, just in this lesson, that 30 does go into 90, and it's 3 times, right? 30, 60, 90. So I'm going to put a 3 right here above the 3 in 93 because that's the number I was checking. 3 times 30 is 90. Oh, but I got to fill my row up here. I keep forgetting to do that today. Fill my row. So I'm really taking 30 sets of 30 out. And when I do 30 times 30, I get 900, and I'm left with just 30, right? And we could put 30 into 30 one time. So I'm gonna put a 1 up here. I'll multiply through just so I'm doing the work the way it's supposed to be done. I'll subtract down and see my remainder is 0. And so my answer is just gonna be this 30 plus 1 here. All right, and we got one more. We got 370 divided by 20. I don't think this one's gonna come out quite as nice as the previous one, but still not bad. It's still nice when they give us a number to divide that ends in 0. That usually makes life a little easier. So let's see here. We got 370 divided by 20. I'm checking to see how many times does 20 go into 3. It doesn't, of course. So now I'm checking how many times does 20 go into 37. Well, if I count by my 20s, it goes 20, 40. The second 20 already gets me to 40. So I'm only gonna be able to fit 1 with a 37. So I'll put 1 here, but I'll fill my row with a 0. So I'm pulling out 10 units of 20 right now, and 10 times 20 is 200. So this is a little tough actually, now that I look at this question, because now we gotta see how many times does 20 go into 170? Ugh. Well, let's think of it as 2s instead. Instead of trying to count by 20s, let's just count by 2s, and we'll think, okay, how many times does it go into 17? Because it's the same thing. 2 into 17 is the same as 20 into 170. So let's go 2, 4, 6, 8, 10, 12, 14, 16, 18. When I count 9 on my fingers, I get to 18. So I don't want that. I'm going to back off 1. I got 8. So we got 8 20s. 8 times 20 is 160. And it looks like I'm going to have a remainder of 10 on this one. And my answer is going to be this 18 up here. 18, remainder 10. All right. Hopefully you were able to get some of those. Maybe you got all of them. Let's do the next lesson as well. And we'll do this similarly. I'll do a couple with you. I'll ask you to do some on your own, show you the answers at the end. And if there's any time left in class after we're able to do that, then you spend the rest of the time in the Math 180 software. If there is any time left, probably won't be much, just a few minutes, which means you got to log on quickly and get right to work if you're going to get anything done, right? Okay, so this lesson has an estimating component to it, which is a really, really good practice for mathematicians to be in, because it helps you do things quickly when you don't necessarily need an exact answer, but it also helps keep yourself in check on making sure that your answers make sense. If you're able to have a decent estimate of your answer before you even start a question, like you know that your answer should be somewhere in the neighborhood of 20, and then you do all the math and your answer is like negative 484, that should be kind of a red alarm that maybe you messed up somewhere in there and you got to go back and double check it. That's the best purpose of estimating for us in a math class. So the way we're going to estimate is just by using some rounding. We will always round the dividend, the number being divided, and the divisor, the number that we're doing the dividing with, to the nearest 10. So for example, 98, that 8 is pushing the 90 really close to 100. So let's round this 98 to 100. And then this 18, that's really close to 20. So let's round that. And so we might not be able to do 19 divided by 18 like really quickly or easily in our head, but we should be at the point to where we can do 100 divided by 20 relatively quickly and easily in our head. And that's going to be 5. So our answer should be somewhere in the neighborhood of 5. And we can actually use that fact to help us do the math more easily, because next we have to do 18 into 98. And well, 18 doesn't go into 9, so I have to figure out how many times does 18 go into 98. Maybe I don't really know, but my estimate just said it was 5. So maybe I should just try 5 and see if that feels right, or if it's a little too high or a little too low. So let's hear 18 times 5. Well, we can count by our 5s, right? We just got to get to 18. Let's start at 50. So we know 50 times 5, I'm sorry, 10 times 5 is 50. So from there, we just go to 11, 55, 60, 65, 70, 75, 80, 85, 90. I'm at 18, right? Because we started at 10, now I've got 8. And so 18 times 5 is 90. And I think that works because if I went 18 times 6, I'd be like over 100. So let's put a 5 here. 5 times 18 is 90. We just figured that out with our fingers a moment ago. And when I subtract down, I got 8. And so our answer is going to be 5 remainder 8. And what they're asking down here at the very bottom, is your answer reasonable? Well, your answer is reasonable if it was close to your estimate. And it was, right? We estimated 5. We got 5, just with the remainder of 8. So I'd say yes, it's reasonable. All right, let's do it again. This time, let's round the 75 to 80. The way rounding works when you're rounding to tens is you look at this number here, the number in your ones position. If that number is 5 or higher, then you round up to the next 10. If that number is 4 or lower, round down. So this 75 is going to round up to an 80. But this 12 is only going to round down to a 10. And we can do 80 divided by 10 in our heads. That's the purpose of this, is to turn this question into one that we can do relatively quick and easy. Even though it's not the exact answer, it gets us something close. 80 divided by 10 is 8. So our answer better be somewhere in the neighborhood of 8. And so we could try just seeing if we can pull 8 sets of 12 out of the 75. But if you have your multiplication chart with you, or if you're kind of good by counting by 8s, you should be able to figure out that that's a little too high, because 10 8s would just be 80, right? So what's 12 8s? 11 8s would be 88. 12 8s would be 96. 96 is going to be way too high. We should not go with an 8 here. So let's backtrack it a little bit. We know that 10 8s gets us 80. Sorry, I'm thinking about 8s when I should be thinking about 12s. We know that let's think of it in, let's drop way down. Let's drop way down to something easier so we can figure it out from like lower up. So what number is kind of easy to multiply by 12? I'm thinking 5. So we know that 10 5s is 50. 2 more 5s gets us 60. So is 5 what we want to put here? If 5 12s makes 60, is that a good answer for here when we're trying to get it into 75? Probably not, because I think we can fit one more, right? From 60, if we add another 12, we would get to 72. And so I think we want a 6 here. That one was hard. That one was hard for me. Maybe it was hard for you. Or I don't know. Maybe you're all just yelling at the screen at me the whole time. 6, Mr. Thomas. I don't know. The 6 times 12 is 72. And so we're going to have a remainder of 3. Oof. Stuff just dropped off my desk here. So our answer on this one's going to be 6 remainder 3. And they want to know, is your answer reasonable? This one's not quite as close as last time, right? Last time it was like perfect. We estimated 5 and we got 5 with a remainder. And last time this time we estimated 8 and we got 6 with a remainder. That's still close enough. That's still decently close to our estimate that I would say, yes, our answer is reasonable. All right, I'm going to do one more as an example, and I'm going to ask you to do the other 3 on your own before I show you the answers, just like we did in the previous lesson. So this time we're doing 70 divided by 11. Let's get our estimate out of the way first. That 70 can just stay 70. That 11 can get rounded down to a 10. So our estimate is 70 divided by 10, which is 7. Answer should be somewhere around there. But see, here's a trick that I haven't talked about yet. We rounded down the divisor, right? We changed 11 into 10. And so 10 can go into 77 whole times. That means that 11 probably can't, right? Like if you can get 7 10s out of 70, then you probably can't get 7 11s. And so that's a piece of information we can use to help us do the question. We know that the answer is probably gonna be a little bit lower than 7. And so let's try a 6. 11 times 6. Well, you just have to do the 6 times the 1 and the 6 times the 1. You get 66. That's really close to 70. Close enough to 70 to where we probably couldn't fit another 11. And so I'm going to put a 6 here. And 6 times 11 is 66. And we get a remainder of 4. So I think that's going to be our answer. Our answer is going to be 6 remainder 4. And that's close enough to 7 to where I would say our answer is reasonable. All right, so same thing as last time. I'm going to ask whoever's teaching this class right now, just pause this video for however long it seems reasonable for students to work on these 3 questions. That could be somewhere between 5 and 8 minutes probably. I think these are a little faster than the ones from the previous lesson. And then when it seems like students are ready, press play and let's go over the answers to those next 3. All right, so hopefully you got some good work in on these 3 questions. Maybe you got them, maybe you didn't. That's okay. Let's see the answers. So 58 divided by 15, I'm going to estimate that as 60 divided by 10. That's a big drop from 15 to 10. And so I feel like even though my estimate is 6, there's no way I'm going to be able to pull 6 15s out of this 58. I bet you the answer actually winds up being a lot less than 6. So let me try 4. I'll drop down by a couple. 4 times 15. We saw that in the warm-up earlier, remember? It's always good to be able to remember stuff like this so you don't have to do any work. We did 4 times 15 right here. 15 times 4 was 60. If we can remember stuff like that, it keeps us from having to do work later on. I'm all tangled up here. I got cords all messed up. Let me give this a second to get back into focus. So I'm not going to be able to put 4 15s into 58 because I know that that's 60. But 58 is close enough to 60 to where I'm pretty confident that it must be 3. Look how much lower we are from our estimate. I estimated 6. It's going to be 3 something. 3 times 15 is 45. I subtract down, I get 13. So what I wind up here with is 3 remainder 13. It's still reasonable though. I mean, our estimate, kind of not that close, but it's not like we're off by 100 or something like that. All right, this time we got 37 divided by 17. I'm going to round that 37 up to a 40. I'm going to round that 17 up to a 20. That's nice. They both rounded up. So the answer should be like relatively close to the estimate this time. 40 divided by 20 is just 2. And I think I'm going to use that 2 this time because 17 times 2 is 34. That's pretty close to this 37 I got here. That's just going to get me a remainder 3. So my answer is 2 remainder 3. I would say yes, definitely the estimate was reasonable this time. All right, and this last one, all my situations all getting all weird angled here. This 83, I'm going to round down to an 80, and this 19, I'm going to round up to a 20. And so 80 divided by 20 is 4. But I'm almost positive, or I'm very positive, that answer is going to be small because I made the dividend smaller and I made the divisor bigger. And that's going to give me fewer times that I can divide into. So the answer is definitely going to at least be 4 remainder something, or it might even be 5 remainder something. Let's see. Well, maybe I should just try a 5 and see if it would work. Like what if I were to say 5 times 19 into 83? Well, that's another thing we saw earlier, somewhere along the line here, is where I said that I know that, oh no, I'm thinking of 25, not 20. But same trick. If I'm going to multiply something 5 times 19, well, I know that 5 times 20 is 100. That's just a fact I've memorized. So 5 times 19 must be just 1 5 fewer than that, which is 95. That 95 would be too big to go in this 93. And so that's enough for me to know that it's got to be a 4 here. 4 times 19, that's the same as 4 times 20, which is 80, except with 1 fewer 4. So that makes it 76. And I subtract down and I get 7. And so what we have here is 4 remainder 7. Yes, I would say our estimate was reasonable, or our answer is reasonable, whatever. All right. Should be a little bit of time left in class. I haven't been timing how long this video is. Or maybe there's not. Whatever. If there's time left in class, please spend it in Math 180 software. If there's not, then have a good rest of your day.